Hello and welcome to NORAD4U.com. Hello, my name is Amir Boston. Today I'm going to test and send the one before the last in VRD100 from the first batch to a customer, this meter. After that I will have only one left to sell from the first batch. And then we're going to go into production with the second batch. And in addition to the test and that the manufacturer does, I'm doing extra tests here to make sure that the meter fits my requirements and also is accurate. And this is how I do it. So this is my test environment. I got my generator, my amplifier, and my station, which is, I built it myself. It consists of a directional antenna and a place to hold the meter. I have a reference meter, which was tested alongside and in comparison to other meters, and I have my unit under testing. In the low frequency, I have other station with two slots, one for milligauss, one for electric field. And now for the test itself, starting to the radiation and transmission, and I'm measuring the RF in the point that the meter is located at. I got about 19.1 milliwatt per square meter. And now I'm doing the same for the unit under testing, getting 21.5, something like that, 21.0 milliwatt per square meter. I'm doing the same for the low frequency magnetic and low frequency electric. I'm using the reference in order to test the low frequency magnetic, getting 9.9 milligauss, and the low frequency electric getting around 23 volt per meter, and redoing it for the unit under testing, getting a 11.8 milligauss. I'm writing all the outcomes on a piece of paper. And now doing it also for electric field, getting 23, 22 volt per meter. So we saw differences between the reference meter and our meter, the meter that is going to go out for the customer. So I'm connecting the meter to the PC via a special cable and operating a special software that the manufacturer has made for me. In this software, I connect to the meter, to the unit under testing, and getting the data from it, the calibration data. Now I'm using the word calibration. It's not really a calibration process. It's more like a setup process or a testing process. It's not a formal official calibration. I'm not a lab. I'm doing it in my home office. And I'm punching in the value I saw, the values I saw on the unit under testing and the value that the reference meter showed in every one of the fields, in RF, in low frequency magnetic, and low frequency electric. And the software calculates the calibration factor that need to be sent to the meter in order to get the outcomes closer to the reference meter. I send the data to the meter and it's saved. Now I will redo the testing in order to make sure that the calibration factor are correct, and the meter is now measuring very close to the, or closer to the reference design, to the reference meter, sorry. This was the reference. Now I'm using the unit under testing, and I'm seeing 90 milliwatt per square meter in both units. This is very nice. Very, very close. Writing it down, and I'm giving the all go for the RF. Moving on to low frequency. First magnetic, and then electric. Now, this is the reference on the magnetic. I get 9.1 milligauss. And around 23 volt per meter. I redo the test with the unit under testing and I'm seeing 9.9, around 9.9 milligauss, which is very nice, very close to the reference. And writing it down, giving the OK for magnetic, and then electric field 23, volt per meter 22, writing it down, again giving it a OK.
Minimize the use of smartphones and wireless devices before the use will minimize you. Don't forget to subscribe, like, share and comment. Thanks for watching and see you next time.